Hello and welcome to Exponentials 1.2, linear versus exponential functions. Okay, so this starts the first real lesson that you guys have never seen before. So I'll try my best to recreate what I would try to do in class if I was there live in front of you, but obviously that's not possible. So I'll try to make this video as close to what I would normally do if I were in the real classroom as possible. Okay, so good luck, and you can. Yeah, good thing about this video is you can rewind anytime you guys want to hear something again or see another step again or hear an explanation of what this step just did too. So that might be actually a good thing also. Okay, so today we're going to compare linear versus exponential functions, and in this lesson we're going to show you guys graphical differences between the two different functions as well as the differences in their equation. Okay, well, actually, you're not really going to see the difference in the linear function equation and that kind of stuff because we're just going to work with the exponential. Linear, you guys should have learned in your Algebra 1 days. Okay, all right, so let's go to our first slide. And notice how I kind of deleted some of the slides that I normally would have if this was live in front of you. So I only left in the slides that I wanted to actually use. Okay, so when you skip through your packet, when I go through my presentation, you're going to notice that the slides that I do have are still going to follow the order of the packet. So yeah, just know that you won't be seeing everything in the slides that you would when you flip through your pages. So I'll try not to go super fast through a page and see if you guys can catch up via that route. Yeah, but nonetheless, you can just hit pause. Yeah, on the video if you guys want to catch up and see where I'm at in the packet. Okay. All right, so in this picture, you're going to see the graphical difference between linear versus exponential function, where linear, it's a straight line because it's based on either adding a number or subtracting a number as far as how high you go or how low you go. And they're going to call that change your m, your slope. Okay, whereas in exponential functions, how high or how low you go is based on multiplication. Okay, whether it's multiplication by a whole number or multiplication by a decimal or fraction. Yeah, so those things can cause the graph to actually rise very quickly, yeah, or rise very slowly. Okay, so in light of what we have in our world today with the coronavirus, yeah, they talk about exponential growth a lot because from one person it can easily grow to a lot of people in a very short amount of time. So they call that an exponential type function. Okay, and those types of functions are measured with the letter b, yeah, as opposed to m for linear. All right. Okay, so making the equation for an exponential function. Okay, this is where it's going to get a little confusing. So you probably might have to pause the video so that you can just literally write down what you see on this slide because I kind of added a lot of stuff. Okay, so the first thing I'm going to try to do is I'm going to try to explain to you what all these letters mean. So you see them all having x, right? X above the left side of the fraction, yeah, where it has f of 1, f of 0, f of 2, f of 1, f of 3, f of 2, and so on and so forth. You see an x right above them, okay? And on the right side fraction, you're going to see a y right above them, all right? So that's just telling you, yeah, the x and the y are just telling you where I'm getting these numbers from. So the 1 and the 0, if we go all the way to this table right here, where it says x, I'm getting the 1 and the 0 from my table. And the corresponding y value right next to it, or what they call f of x, but I'm going to call it a y, okay, they put a 1 and a 3. So that's why right next to the 0, in this fraction all the way here, you're going to see a 1. And right next to the x value of 1, you're going to see a y value of 3. So all I'm doing is I'm grabbing the numbers from this table, and I'm putting it into each of these equations. Okay, so just like here, right, x is 5. So here's x is 5. His y value is 243. So right next to x of 5, you see 243. Okay, and x value 4 in my table. Y value is 81. Y value is 81. So notice how this is just pretty much the ordered pair: 4, 81, 5, 40, 243. Right? 3, 27. Just like here in your table, 3, 27. And 2, 9 right here. And 2, 9 right here in your table. Okay, and 1, 3 here. And 1, 3 here in your table, and 0, 1 here, 0, 1 in your table. So all I'm doing is I'm grabbing my numbers from my table, my x's and y's, and I'm plotting them into this set of fractions. Okay, but you need to make sure you put the right numbers in the right spot. So that's why I said, right, that's why I have an x above this left side fraction, because only the x values are allowed to go in the parentheses that are connected with the f parentheses x value. Okay, and in the right side fraction, these are your y values. Okay, x values, y values, and so on and so forth. Okay, so this last number right here, the 3, this tells you your b value. And if you remember from the previous slide, your b value is going to be basically how fast your graph is either going to rise or how slow it's going to rise. Yeah, so this is kind of like your slope, right? In a linear graph, slope is m. In an exponential graph, your value that makes it rise faster or slower is going to be known as your b value. Okay, so this last number here tells you your b value is 3. So every single time your graph is going to get bigger, it's going to get bigger by 3 times as much. Okay, so why do I have a difference of 1? Well, this difference of 1 is from the x column, where if you look at your two x numbers, 1 and 0, that's a difference of 1, right? 1 minus 0 is 1. This is a difference of 1 because if you look at your x values, 2 minus 1 is 1. This also is a difference of 1 because x value 3 minus 2 is 1. And so all these differences are all 1s because when you subtract your x values, 1 minus 0, 2 minus 1, 3 minus 2, 4 minus 3, and 5 minus 4, these guys are all differences of 1. Okay, and that's kind of important. You'll find out why it's important in the next slide. But as far as an understanding that your difference is 1 is going to be kind of important in your calculation of the b value. Okay, so just understand that your differences all come from your x's being subtracted. Okay, so when you guys make your own fractions, because one day you're going to be getting a table without these fractions being made for you. So when that happens, you're going to follow this skeleton form right here, where you're going to have f blank parentheses divided by f blank parentheses. And that's going to be all your x numbers in those two blanks. And on the right side, it's going to be the corresponding y value of that x. Okay, so if this is a 1, then this was 3, like in that first fraction up here. If this was a 0, then this is 1. And these are all going to be the numbers you get from your table. Okay, and when you divide the top and the bottom, you're going to get your b value. Okay, so please, 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 you're going to need to know this for the entire lessons 1, 2, and 3, if I remember correctly. So this is going to be super important, and you're going to see this happen a lot in your problems in the next couple of lessons. Okay, all right, let's go on to the next slide. Okay, so these are all values from the same exact table that we have on the previous slide. Okay, I can't go in, I can't point to it right now, but you guys have your packets. You guys can literally just look at your packet, look at the table, and see that these numbers are straight from your table. Okay, but the difference in this is, now what do all your differences say? Your differences say 2 for these guys, and your difference is 3 for these guys. So how does that make a difference in finding your b value? Well, look at what we have here on the very right side, right? In the last problem, the last slide, we had a 3 in that spot, right? These are all 3s, okay? But here's how you eventually turn all these 9s into a 3, okay? So this 9 is because you don't have your b value anymore. So in a difference of 2 scenario, this 9 is known as b squared, okay? So this difference of 2 says we don't have our b yet. Okay, if this said difference of 1, we would have our b value, and we would just stop right there. We don't have to do anything else because we found our b value, we're good to go. But in a difference of 2 scenario, this is not the b value. This is known as b squared. So how do I turn a b squared into a b? Well, you guys learned that in the last quarter when you guys are still in the classroom, right? To get this to become a regular b, you square root b squared, you get b. And you square root 9 and you get 3. And that's how we get b equals 3, because taking a square root of both of these things will get you a b value of 3. Okay, in this next scenario, look at all your differences now. These are all differences of 3. So now look at your number here. It used to say 9 in the previous example. It used to say 3 in the slide right before this, but now it says 27. Okay, all of these guys say 27, 27, 27, right? All 27s. Okay, and this is the result of this 27 being known as b to the third. Well, how did I get b to the third? Well, look at all my differences, right? If I look at all my x's, 3 minus 0 is 3. 4 minus 1 is 3. 5 minus 2 is 3. So these are all differences of 3. So that tells me that whatever number I have here is not known as b to the first power, which is what I want actually. It's not known as b squared because this is a difference of 3. It's known as b to the third. So to get this to become regular b, you have to ask yourself this question. Okay, so if b times b times b equals 27, what's the only number that can fit in place of this letter b? So what number times itself 3 times makes 27? And that answer is 3. So therefore you have your b value of 3, just like we had the b value of 3 here and the b value of 3 in the previous slide, because all these numbers come from the exact same table. Okay, so please keep in mind, yeah, that the difference right here is huge in determining your b value, because whatever you get here when you divide it out will tell you what type of b you have. So in this difference of 2 scenario, we have a b squared number right there. In this scenario right here, difference of 3, this is a b to the third power. Okay, and if we ever get b squared or b to the third, we have to make sure we turn these into regular b's. Okay, so the whole point of this whole 2 slides are how to find b. Okay, that's the whole point of these 2 slides. It's how to find b, because we're going to start making equations. Yeah, equations of exponential functions, and they're based on a b value. Yeah, just like in linear functions, when you found linear functions, you were told to find slope, yeah, or your m value. So in exponential functions, you're going to be told to find your b value. All right, so please know how to set this equation up, because as I start doing the problems as examples, you're going to see me writing this equation pretty much every single time I start a problem. I'm going to start with this. Okay, so right now we're going to make our equation based on the numbers we have. So notice how this is not a table, but they still do tell us coordinates. Okay, so watch what I do right off the bat. Okay, I might extend this page because let's change it to. Can I do that? Yeah, I can do that. Okay, so watch what I do. I'm gonna write the blank equation right off the bat. Okay, I'm not gonna fill it in with anything, but I'm just gonna write that right off the bat. And then I'm gonna get a number, and that's gonna be my b value. And I'm gonna do it for both of these problems because I'm planning on showing you guys both answers. Okay. And when I get this regular plain old number right here, that's going to be known as b. Well, hopefully it's known as b. Yeah, depends on what my difference is. Okay, so let's plug in our numbers. So we have 0, 6, 1, 18, and 2, blank. So do you think we can use this 2, blank one to fill in our 4 values here? No, because this coordinate is incomplete. So I don't want to even touch this coordinate just yet, because he's going to leave one of these spots blank, and if I have one of these spots blank, I cannot find b. So I have to use coordinates that are fully complete. So 0, 6 is fully complete, 1, 18 is fully complete, so I'm going to use those. Okay, so you just cannot put these numbers any old place you want though. Okay, so the numbers that have to be in a certain spot are the x's. The x's are real strict as far as where you put them. Okay, so your x values in the coordinates that we're going to use are 0 and 1. Okay, so the rule for these x's and the placement of them is this. Always put the bigger x on top. So we have an x of 0 and an x of 1. Who's the bigger x, 0 or 1? Well, I hope you guys all said 1. Okay, so 1 is on top, 0 is on the bottom. Okay, so right now, what kind of difference are we looking at? We're looking at a difference of, well, subtract 0 and 1. What do you get? You get a 1. So we're looking at a difference of 1. And why is that important? Because whatever number I get here, that's going to be known as b. That's the number I actually want. I want b. I don't want b squared. I don't want b to the third. Well, I mean, I can get them, but I eventually have to turn b squared and b to the third into regular b. So if I have control of anything, I want to make sure I have a difference of 1 if I can control the numbers that I put in these spots. Okay, so what is the y value that corresponds to 1? Does 6 correspond to 1? No, 6 corresponds to 0. So this 6 is going to go right next to the 0, so it's going to go in that spot. So what y value corresponds to 1? Well, let's look at my coordinates. What 18 does. Okay, so I divide this out. 18 divided by 6, I get 3. So that's my b value. Okay, and that's kind of important because that's going to be how I go and find out this number in the blank eventually. Okay, but I'll do that later on. Let me go to this next problem, b. Okay, so now let's look at all my coordinates. So 0, blank. Do you think I can use him to fill in these 4 spots? Well, I hope you said no. And the reason why you cannot use this coordinate to fill out any of these 4 numbers are we need to only use complete coordinates to fill out these 4 spots. If I don't have a complete set of coordinates, I don't want to use that number to fill out these spots because one spot's going to be left blank, and if one spot is left blank, I cannot get my b value. So the only coordinates you can use to fill out these 4 spots are complete coordinates. So 1, 2, is that a complete coordinate? Yep. 2, 8, is that a complete coordinate? Yep, so I can use 2, 8 and 1, 2. So when I start filling out my first column, these are my x's. So x is 1 and x is 2. So what did I just say as far as which x goes in which spot? You always want to put the bigger x on top. So is x equal 1 bigger or x equal 2 bigger? Well, I hope you said 2. Okay, so 2 is bigger, 1's on the bottom. So what kind of difference are we looking at for this problem? Difference of 1. So is that the kind of difference I want to see? Yes, because difference of 1 means whatever number I get right here, that's my b value, that's what I want. Okay, so 1, 2, so here's my 1. 2 is his y value, so I put that right next to him. 2, 8, 2 is right here, so I put an 8 right next to him. Okay, so divide this out, I get 4. So my b value is 4. Okay, so how do we use that to our advantage? Well, like I just said, this 3 tells you how I go from one y value to the next. Okay, so I haven't really explained that part as far as what the role of b is, but I'm going to do that right now, so make sure you pay attention. Okay, your b value tells you how you get from one y value to the next. So if I go 6 times 3, which is my b value, I get 18, right? Okay, so if I go 18 times 3, what number do you think I get? Well, hopefully you say 54. Okay, and that's the role of b. B tells you how you get from one y value to the next. Okay, so for this one, right, 2 times 4, do I get 8? Yep. Okay, now comes the hard part though. Now we got to go backwards. So basically it's this number times 4 equals 2. Okay, so we got a number right here times 4, and that's going to equal 2. Yeah, so let's do that. Number times 4 equals 2. So how do I solve for the number symbol? Right, I want to get rid of the 4. How do I solve for the number symbol? Well, I divide by 4, and I get number equals 2 over 4, which is known as 1/2. So I put a 1/2 right here, 1/2 right there. And there you go. Okay, so since this is a video, if you guys need to see that again, just remind. Yeah, it's not like live class where I got to repeat things. So going on to letter C. Okay, so first thing we want to do is we want to find the b value. Second thing we want to do is to fill in this blank. Okay, so now we have a lot of options for x's and y's. Okay, but like I said earlier, first thing you do when you arrive at a problem, you want to write your blank form. Okay, so I'm going to do both C and D, so I'm going to write my blank form. Okay, so that's my advice. Yeah, write this as soon as you get to the problem. All right, so now I have options. Okay, so I could choose this, and I could choose this for my numbers that I want to plug into my formula. So I put 3 here, I put 0 there because, like I said, right, you always put x's in this column, and you always put the bigger x on the top. Okay, then I put 40 here. Ooh, actually, I won't even write the 40 yet because I want to tell you guys why this is not the route you want to take. Okay, when I start doing difference, I'm going to get 3. Okay, is a difference of 3 the scenario I want to have? No, because eventually when I get this number right there, this is not going to be known as 3. This is going to be known as b to the third. So I got to do extra work in that sense. So if you have any control over the problem, you want to try to avoid difference of 3 as much as you can. So notice how they did give me a lot of values. And do I have values that are actually right next to each other? I do, right? I have lots of values that are right next to each other. I don't have to pick 3, 40 and 0, 5. I can choose other values that are closer in distance as far as the x's are concerned. Okay, so I might be better off choosing 0, 5 and 1, 10. Yeah, so when I put my x's in this first column, like I said, right, which x value always goes on top? The bigger one. Smaller x goes on the bottom. Okay, and what's the corresponding y value for the 1? 10. What's the corresponding y value for the 0? 5. So when you divide this out, well, actually, no, before I divide it out, I can confirm that I have a difference of 1. Okay, so I have a difference of 1. And because of that, when I divide this out, I get a 2. So that's my b value. Okay, And that's the kind of b-value I want to see, a difference of 1 b-value. So I don't got to do anything funky, anything special to this 2 at all. I just leave it as is. Okay, so now let's look at these. Okay, so these numbers aren't as pleasant because they have a lot of negative numbers, right? These guys are all negative numbers. The x values, they're not all, but -2, -1. Those are my negative numbers. So I definitely want to pick this guy as one of the numbers I want to work with because that's a nice easy number to work with. Okay, and I probably want to pick -1, 6 because they're right next to each other. This is gonna make a difference of 1 scenario. So that's what I want to see. I don't want to see a difference of 2 scenario. I only want to see a difference of 1 if I can help it. Okay, so now here comes the hard part. What's bigger, 0 or 1, -1? Okay, so hopefully you say 0 is bigger. I know a lot of you guys are not real strong with negative numbers even to this day. Okay, but hopefully you guys remember that when you look at a number line, right? The numbers on the right hand side are always bigger on our number line. The numbers on the left are always smaller. So if this was a number line, okay, if this is a number line, 0 would be here, -1 is there. So like I said, the numbers on the right side of a number line are always bigger than the numbers on the left. So that's why 0 is bigger, -1 is smaller. Okay, so that's why we're going to arrange the x's just in this way. Okay, so the y value that corresponds with 0 is 2. The y value that corresponds with -1 is 6. So when I divide this out, simplify your fraction, you get 1/3. So your b value is 1/3. Okay, so why are these so important? Well, like I said, it helps you to get from one y value to the next. So if I go 5 times 2, do I get 10? Yes. If I go 10 times 2, do I get 20? Yes. If I go 20 times 2, do I get 40? Yes. If I go 40 times 2, what do I get there? And this is where you hopefully say 80. Okay, and that's the role of what b does. He helps you get from one b value to the next. Okay, so just like this one, 18 times 1/3 is 18 over 3, which is 6. Okay, and 6 times 1/3 is 6 over 3, or 2. Yeah, so notice how we're getting the next number in the column, yeah? So 18 became 6 because I multiplied by 1/3. 6 became 2 because I multiplied by 1/3. So what is my 2 going to become? Well, let's just do that work on the side. So 2 times 1/3 equals 2/3. So you put 2/3 in this column. Okay? Alright, so that's C and D. Let's move on to the next one. Yeah, like I said, sorry I'm going by fast, but like I said, this is a video. If I go too fast, you can always rewind, right? You don't have to watch this. This is not live, yeah, in that sense. Okay? So, right, next problem. Okay, so like I said, first thing you do is you want to make your blank equation. Yeah, because you want to find your b value, and your b value is going to help you get all those blank y values that are in this problem. Yeah, because you see actually 2 coordinates that are blank in this problem. So yeah, we really need to get a hold of that b first. Okay, so this one too, I'll show you guys. Like right, first step always the same, right? No matter what the problem is, first step is always the same. Go after your b value based on this blank equation. Okay. All right. So what are my 2 complete coordinates? Well, this guy is a complete coordinate, and this guy is a complete coordinate. Okay. These guys are not. Right? These 2 coordinates are not complete, so I cannot use them. They're missing their y values. Okay. So when I use the 2 complete coordinates, 1.6, 80, 0.6, 8, don't get freaked out by these decimals. It'll work out nicely in the end. Okay. So 1.6 and 0.6, which one is bigger? Well, hopefully you say 1.6. And when you subtract these 2 things, you get a difference of 1. So yeah, the decimals, the x values are ugly, but you still got a nice difference of 1. Okay. Okay, so I'm going to start erasing these circles and arrows because I'm going to eventually have to start using this space right here. So I'm going to erase this out. Okay. So what is the y value associated with 1.6? 80. And what is the y value associated with 0.6? 8. And when you divide that, you get 10. So your b value is 10. Okay. For this next one, okay, these ones are not going to be as pretty because it's going to be your first time where you're going to kind of be forced to have a difference of not 1 anymore. Okay, so this one's missing. This is the one that we wish we had because they would be x values that are right next to each other, so difference of 1 scenario, but we don't have that. Okay, so we have an x value of 1, we have an x value of -1. So 1 is bigger, -1 is smaller. Like I said, bigger x value on top always. 49 connects to that 1, and a 1 connects to the -1. So when I divide this out, I get 49 which is known as b squared. Okay, this is a difference of 2 scenario. So I forgot to write that out. Sorry about that. Difference of 2. This is a difference of 2 scenario. So when I get this last number here, he's not known as b, regular, plain old regular b. He's known as b squared because my difference was 2. So just ask yourself this question. What number times itself makes 49? And being that you're in my class and you guys are told to memorize all your perfect squares, you should already know that this is going to be a 7. So that should hopefully be easy. Hopefully you guys are maintaining knowledge while you guys are away from school. If you guys are not, well, you better get on it, people. Seriously. Okay, so why are these b values so important? Well, because it helps you to get from one y value to the next. And if you forgot how that works, just watch. Okay, so here's a y value of 8. Times it by 10. Do I get 80? Yep. So 80 times 10, oops, how come it's not right? 80 times 10, that should get me this value, which is 800. Okay, the part that you guys don't like is when I gotta go backwards. So we don't know this one right here, right? We don't know that number right there. But we know that if I multiply by 10, we're gonna get 8. Okay, so number that we don't know times 10 equals 8. So let's write that out as an algebra equation. So number times 10 equals 8. Okay, right? Isn't that what we have here? Number times 10 equals 8. 8 times 10 equals 80. 80 times 10 equals 800. So that's how this pattern works, right? It's always the previous y value times 10, which is your b value, equals your next y value, right? Y value times b equals next y value. Y value times b, which is 10, equals next y value. Okay, so that's what our pattern is. So we don't know this number. We're going to multiply it by the b value, and we're going to get the next y value of 8. So how do we solve for the number symbol? Divide by 10, divide by 10. So we get number equals 8/10, or known as 4/5. Okay, so 4/5. Okay? Okay, so this next one. So what do we got? We got 1 times 7 equals our next y value, which is 7. And just to make sure it works, we're going to go with this number times 7. And does that make 49? It sure does. Okay, so it works. Okay, next one. Okay, so now they have us at tables again. So let's write the blank equation like I told you guys we're going to do for every single problem for this whole entire, I think, 3 sections. We're going to start with this. Well, I'm pretty sure we're going to start with this every time. Okay, oops, maybe I didn't leave enough space between the equal sign and the b. Maybe I did, who knows, I'll just write it again. Okay, so f of blank divided by f of blank equals fraction bar equals hopefully regular plain old b. We'll see. Okay, so these are the 2 coordinates I'm going to use, right? Remember I said you can only use complete coordinates to fill in your numbers. So in this column, you're going to put the bigger x value. So you got a 1 and a 0 is your x value. So let's put the bigger one up top, smaller one on the bottom. And who corresponds with 1? 90 does. Who corresponds with 0? 100 does. Okay. So let me just erase these because I don't want it to get real crowded up there as I show you guys the next couple of steps. Okay. So when I divide this out, when I simplify it, divide by 10 on top and bottom, so I get 9/10. And my difference is 1. Sorry, I forgot to put that. Difference is 1. And why is that difference equal 1 so important? Well, it tells me if that's my true b value or if I have to do anything else to it. So since this is a difference of 1, that's my real legit b value. No changes necessary. Okay, so this b value is important because he tells me how to get from one y value to the next. So 100 times, oops, why isn't it writing? Times 9/10 equals 900 over 10, or 90. Is that the next y value that's in my table? Yep. So how do I get my next y value? Well, 90 times 9 over 10 equals 810 over 10, which is 81. So I put 81 here. Okay? And that's why it's so important to get the b value, because he tells you how to get the next y value. Okay? All right, so as you look into this next problem, I think, yeah, this next problem, you're not going to be really happy about this next problem because look at all your blanks. The only complete coordinates I have are this one and this one. You got a whole bunch of spaces in between, so that's not going to be fun. So 7 up top because that's the bigger x value, 4 on the bottom. This is 64, this is 1. Okay, so this is going to be a difference of 3. So right away I could just put b to the third right there. because I know it's going to be a b to the third scenario. So we got 64 here. Okay, so same thing. To get this to become regular b, we just ask the question, what number, when multiplied to itself 3 times, equals 64? And this is also another scenario that I told you guys to memorize, your triples, right? So hopefully you guys remember your triples. Okay, so what number when multiplied to itself makes 64? And hopefully you all say 4 is the answer. Okay, so you have a b value of 4. So why is that b value important? Like I said many times already, it tells you how to get from one y value to the next. So times this y value of 1 times your b value of 4, you get 4. So I put a 4 here. Then times this y value times 4, and you get your next y value, so that's 16. And if you don't believe this works, just times 16 by 4, and you should get 64, which is your next y value. Okay? All right.